Hey, welcome back to welcome back to Judgment and Decision Making. We just got done talking about language. We're going to talk about problem solving now, and we're just going to start with sort of a general discussion on problem solving. What is a problem? Like, what's a problem space? What's the general idea with solving problems? So this is the general idea, really. You traditionally speaking, right, when you have a problem that you're trying to solve, you think about your goal state. What problem am I trying to solve? What's the solution I'm seeking here? um, you think about your current state. Where am I in with regard to this goal? And you sort of calculate, theoretically, the goal state minus the current state, and that is the distance to your goal. Okay, so you've got a goal state, you've got your current state, and your distance to goal is going to be how far you need to go, what you need to do to get to that goal, right? And the strategy here for problem solving, the big thing that we always want to do is reduce the distance to the goal. The closer to the goal you get, the better you're doing at the problem solving. Okay, easy enough, right? Now, when we think about solving a problem, we have to think about what's a problem. Okay, if we're going to solve it, we have to know what it is. So theoretically speaking, what is how do we conceptualize a problem? Well, scientifically speaking, we talk about searching through problem spaces. Okay, so a problem essentially has a set of steps that need to be taken in order for it to be solved. Okay, and that set of steps is going to be your problem space. Okay, but not just that set of steps necessarily, but all potential steps that you could take with regard to that problem, that is your problem space. All right, and your problem space is going to be a set of states. Okay, your initial state, where did I start? Your current state, where am I now? And your goal state. Everybody say hi to the lawn guys, because once again I'm recording on lawn day. Okay, so a pretty famous problem that we talk about when we talk about problem solving is this Tower of Hanoi. Okay, it's otherwise known as the Tower of London. So we think about this, given some initial state, okay, and in this case, all the pegs are here. We want a goal state. Okay, so I want you to move all these pegs over here. Okay, but there are rules to this task. Now, you can only move one disc at a time. Okay, so you can't just like pick all three up and move them over here. And you can't put a larger disc on top of a smaller disc. You've all probably played this game, right? We can do a little bit of a demonstration here. So we've played the game before, like this, like that, like that, and like that, right? Moves 7, minimum number of moves 7. Adhering to all of the rules there, we were able to get the discs off of this one and onto this one. Now, I didn't move them all to Tower 3, but I can do that if we're really picky and choosy about it. There we go. 6, 7. Well done. All right, good. So we did it. That's the Tower of Hanoi problem. Now, what exactly is the problem space for that problem? Okay, it's going to look something like this. That's like, what? But think about it. Okay, we have an initial state. This is our initial state, right? All of the loops were over on this peg. We call them donuts. Okay? And then we had to make moves. Okay, so from here, what can you do? Well, you can move the smallest peg. Where can you move it? You can either move it here or you can move it here, right? So from here, these are your two possibilities. From these two possibilities, you can now, like, oh, I need my pen. Okay, so from here, right, I can move the small disc over to this peg. I can do something like move the medium disc over to this peg, right? That's pretty much all I can do from there. From here, I can move the small disc back over here. I can move the small disc over here. And that's pretty much where we're going with that. Do you see what you see what I'm doing here? So every one of these states has a set of potential moves that you can go to from there. Okay, so whatever current state you're in is going to have a different number of potential moves. Okay, so when you look at all the moves that you could potentially have from your initial state, that is the problem space. So you can imagine in a game like chess, right? Think about the problem space for a game like chess. It's not just three donuts and three poles, right? There's a lot more going on in a game of chess. Okay, but simply put, the Tower of Hanoi is a great way to demonstrate the problem space. Okay, when we talk about problem spaces, it's really important to remember that you have to be able to, you kind of have to represent, you have to be able to represent that space. Maybe not all at one time, but given your current state, you have to be able to mentally represent what your next options are. Okay, if you're going to successfully solve the problem. Now, yeah, you can solve problems by taking steps that just happen to be the correct ones because you didn't know any other steps to take, right? But you're more likely to get a correct answer if you can accurately represent the problem space. You also have to be able to recognize the goal state that you're trying to reach. If you don't know what goal you're trying to reach, you just kind of move on forever and your problem space is just this indefinite blob. And, that's not problem solving. You also have to know what you can't do, okay? When you know what you can't do, then you pretty much know what you can do. And knowing what you can't do is very important to being able to accurately represent a problem space. Okay, so now we know a little bit more about problems and what they are. So now let's talk about how, what kind of strategies we use to solve them, and the walls that we hit when we're trying to use those strategies. Okay, so I'll see you in the strategies lecture.